Welcome to Rayat Shikshan Sanstha Satara's Rayat Online School Education Project for 11th Science. Myself, Mrinmay Chapekar from Yashwantrao Chavan Institute of Science, Satara. Today we shall start studying the topic Laws of Motion. And in today's session, we'll revise Newton's laws of motion, see what is Aristotle's fallacy, and the difference between inertial and non-inertial frames of reference. We know that mechanics is the branch of physics that deals with the study of motion. Motion is the change in the position of the body. Mechanics can be divided into two branches. One is statics and the other is kinetics. In statics, we study an object at rest or in equilibrium under the action of balanced forces. And in kinetics, we deal with the actual motion of the body. Kinetics can be again divided into two branches, kinematics and dynamics. In kinematics, we actually describe the motion of the body, but without discussing the cause of the motion. And in dynamics, the various motions of the body are discussed, but along with the cause of the motion. So in kinetics, we discuss the parameters, distance covered, speed, or displacement, velocity, acceleration. And in dynamics, along with these parameters, we deal with the parameters like force, energy, work, power, etc. We shall now discuss different types of motion. Linear motion, circular motion, parabolic motion. We are not going to discuss the motions in detail. Simply, we shall discuss the direction of initial velocity u and the direction of acceleration a in different types of motions. So, in linear motion, the initial velocity u may be 0 or may not be 0. If u is 0, the acceleration a in any direction will give linear motion. If u is non-zero, then acceleration a must be in line with u for resultant motion to be linear. In line with, that is, a must have the same direction as that of u, or it will have the exactly opposite direction as that of u. Then the resultant motion will be linear. In case of circular motion, initial velocity is not 0 and acceleration is perpendicular to the velocity throughout the motion. This kind of motion will be circular motion. In parabolic motion, the acceleration is constant and initial velocity is not in line with acceleration. The example of this kind of motion is trajectory of a projectile motion. This motion will be parabolic. Aristotle's fallacy. See the statement. An external force is required to keep a body in uniform motion. Is it true? No. Fallacy is mistaken belief. And it was probably based on the common experience of a ball, say of a ball that is thrown. आपण हे example in detail बघूया. समजा एक बॉल फेकला तर तो थांबेल का? थांबेल. मग का थांबेल? तर सपोज तो खडबडीत पृष्ठभागावरून जातोय तर तो काही अंतर जाईल आणि थांबेल. जर सरफेस अजून थोडा गुळगुळीत केला तर तो अजून जास्त अंतर जाईल आणि मग थांबेल. सरफेस अजून गुळगुळीत केला तर तो अजून जास्त अंतर जाईल. Surface is made frictionless, the friction 0 केलं, then the ball will not stop at all. That means for a body to move in uniform motion, simply initially we have applied a force that is sufficient. But then the body stops because of the opposing force or the resistive force, frictional force. That is what is everything is said in Newton's first law of motion that you know, right? Actually, the correct explanation of Aristotle's fallacy was given by Galileo. He showed that all the objects stop moving because of some resistive or opposing forces like friction, viscous drag, etc. That means that additional force, external force is required for overcoming these opposing the resistive forces. And if the ball is given initial velocity, then if there is no unbalanced force acting on it, it will continue to move infinitely. That is what is stated in Newton's first law of motion, right? So we'll now see Newton's laws of motion. Newton's laws of motion, we already done till 10th, right? We'll simply revise. See the statement of Newton's first law of motion. Every inanimate object continues to be in its state of rest or of uniform unaccelerated motion unless and until it is acted upon by an external unbalanced force. Newton's first law of motion shows an equivalence between state of rest and state of uniform motion along a straight line, as both need a net unbalanced force to change the state. It defines force as an entity that brings about a change in the state of motion of a body, and inertia as a fundamental property of every physical object by which the object resists any change in the state of motion. थोडक्यात काय तर एखाद्या रेस्ट पोझिशन मध्ये असलेल्या बॉडीवर फोर्स अप्लाय केला तर the body will set in motion and it will continue to move infinitely. It will stop only if an external unbalanced force acts upon it. We shall now revise Newton's second law of motion. The rate of change of linear momentum of a rigid body is directly proportional to the applied force and takes place in the direction of applied force. The rate of change of linear momentum, that is dp by dt. P is linear momentum. Its rate of change, that is dp by dt, is directly proportional to force. Here constant turns out to be 1. So F is equal to dp by dt is the mathematical formulation of Newton's second law of motion. P is equal to mv. So d by dt of mv, F is equal to, if mass of the system is constant, then only we can say m dv by dt, and as dv by dt is equal to acceleration, we can say F is equal to ma. If mass is constant, then only we can say F is equal to ma. Otherwise, we should write Newton's second law of motion as dF is equal to dp by dt. See, this is the mathematical formulation of which is used to do calculations. Here, second law, it defines momentum instead of velocity as the fundamental quantity. One more importance is Aristotle's fallacy is overcome by considering resultant unbalanced force. We shall now explain this. See, if force is 0, that is force acting on the body is 0, then dmv by dt will be 0. Now the denominator dt cannot be 0, that means this term has to be 0. That is, momentum is constant, dp is 0, that is change in momentum is 0, that means momentum is conserved. Or if mass is constant, we can write dv is equal to 0, that means velocity remains constant. म्हणजे जर बॉडीवर ऍक्ट होणारा फोर्स 0 असेल तर त्याची वेलॉसिटी कॉन्स्टंट राहील. दॅट इज वेलॉसिटी विल रिमेन सेम if force acting on the body will be 0. This is what is Newton's first law. Now we shall go to Newton's third law of motion. Newton's third law. To every action, there is equal and opposite reaction. It defines action and reaction as a pair of equal and opposite forces acting on the same line. Action and reaction forces are always on different objects. The question that is often asked about Newton's third law is, if action and reaction forces are equal and opposite, do they cancel each other? The answer is no, because action and reaction for forces act on different objects. Action and reaction force pair can be non-contact forces also. For example, a gravitational force between Sun and Earth. A gravitational force between Sun and Earth is an example of non-contact forces. To learn what is inertial and non-inertial frame of reference, we shall consider an example of car moving with constant velocity. Imagine yourself sitting in such a car. या गाडीच्या म्हणजे रस्ता आहे त्याला अजिबात खाच खड्डे खळगा अजिबात नाही. खूप स्मूथ रोड आहे. गाडीला खिडक्या नाहीत. गाडीचा चालवताना आवाज येत नाही. आणि आतमधली अरेंजमेंट अशी आहे की जी एका खोलीसारखी आहे. तर विल यू कम टू नो दॅट द कार इज मूव्हिंग? गाडी जाते पळते असं वाटेल का? गाडीला खिडक्या पण नसल्यामुळे बाहेरची झाडं पळताना दिसणार नाहीत. So if you think over this situation, the answer will be that you will feel that the car is not moving. So आपल्या दृष्टीने आपली कार मूव्ह होत नाहीये. यासाठी आपण एका बंद खोलीत बसलोय अशी सिच्युएशन असेल. Now suddenly the brakes are applied so that the car comes to stop. So what will happen is we'll feel a jerk. If the brakes are applied in the backward direction, we'll feel jerk in the forward direction. हा आपला नेहमीचा अनुभवच आहे. आपल्यासाठी आपण कारमध्ये बसलेलोच नव्हतो. मूव्हिंग कारमध्ये आपण एका बंद खोलीत बसलेलो होतो. तर आपल्याला कारच्या वेलॉसिटीची जाणीवच होत नव्हती. तर how can one explain the reason of the sudden jerk? That is the question. One answer can be like this: if you have applied a brakes to car, to every action there is equal and opposite reaction. But that is not going to be the answer. Just because if the brakes are applied to a car, the car will stop. That is action reaction pair. आपण या सिस्टीमचा भागच नाहीये ऍक्शन रिएक्शनचा. So how to explain the sudden jerk is a question. The answer lies now in the acceleration of the frame of the reference. The frame of the reference associated with the car moving with constant velocity is called inertial frame of reference. That is, the frame of reference which moves with constant velocity. Zero velocity or state of rest is also, you can say, a constant velocity because the velocity is zero. That is inertial frame of reference. And a frame of reference which is accelerated, that is when the brakes are applied to a car, there is a change in its velocity. That frame of reference that is the car is accelerated. So accelerated car is an example of non-inertial frame of reference. Here we can understand the difference between inertial and non-inertial frame of reference. Car is a frame of reference. Initially, when it is moving with constant velocity, it is inertial frame of reference, where acceleration is zero. Later on, when the brakes are applied, the car becomes accelerated, which is non-inertial frame of reference. A person is sitting initially in the inertial frame of reference, and next it is sitting in the non-inertial frame of reference. In the inertial frame of reference, Newton's first law of motion is obeyed, that is, no force acting on the body, no acceleration. In the non-inertial frame of reference, where the car is accelerated, there was actually on the a person is sitting in the non-inertial frame of reference. There was no force acting on a person, but still the person felt an acceleration. The jerk, that is an acceleration. That is Newton's first law of motion was not obeyed there. This is the second difference. Now we have to assume the existence of the pseudo force. The jerk that was felt was the pseudo force acting on a person sitting in the non-inertial frame of reference. Pseudo force is equal and opposite to real force. That is, if the real force is the brakes which are applied to a car, and the pseudo force is experienced by a body in the non-inertial frame of reference, which is exactly opposite to the real force. In short, inertial frame of reference is a frame of reference moving with constant velocity. The velocity can be zero also. And non-inertial frame of reference is a frame of reference which is accelerated one, that is where the velocity changes. In the first case, the acceleration is zero. In the inertial frame of reference, the force that is acting on a body is a real force, and in non-inertial frame of reference, the body in the non-inertial frame of reference experiences a pseudo force which is exactly equal and opposite to a real force. Newton's first law of motion is applicable in the inertial frame of reference, and Newton's law of motion is not applicable in the non-inertial frame of reference. Here we have to assume the existence of pseudo force in the non-inertial frame of reference.